Previously, we looked at erythropoiesis and the stages involved in erythropoiesis. We also looked at the driving force in erythropoiesis, and we did mention that the key driving force in erythropoiesis is the hormone called erythropoietin, which is produced by the cells of the kidneys. In today's lesson, we shall be looking at the process of leukopoiesis. So leukopoiesis actually means the production of white blood cells. The word part leuko in the language of medicine means white, and poiesis means production. Therefore, if poiesis means production, then leukopoiesis simply means the production of white blood cells. Just as we began erythropoiesis with the hematopoietic stem cell, similarly, leukopoiesis will also begin with the hematopoietic stem cell. So, we shall begin with the hematopoietic stem cell. Recall that all the stem cells have a potential, and this hematopoietic stem cell, because it has the ability to give rise to all the blood cells, this hematopoietic stem cell is said to be a pluripotent stem cell. So this hematopoietic stem cell is a pluripotent hematopoietic stem cell. And this pluripotent hematopoietic stem cell will actually undergo differentiation. Remember that we are starting with an undifferentiated stem cell or an unspecialized stem cell. So this undergoes differentiation to form two important stem cells. So it undergoes differentiation to form or to give rise to the myeloid stem cell and the lymphoid stem cell. So we have the myeloid, stem cell, the myeloid stem cell, also called the myeloid progenitor. Remember that the progenitor cells actually are the early descendants of the hematopoietic stem cell. And we have the lymphoid progenitor here. So we have the lymphoid progenitor or the lymphoid stem cell. So these myeloid progenitor cells and the lymphoid progenitor cells, they are actually stem cells. They are all stem cells. And once they are stem cells, then they carry a potential. What type of potential are these stem cells carrying? The myeloid progenitor stem cell can give rise to more than one type of terminally differentiated cells in circulation. For this reason, or because of the fact that it is able to give rise to more than one terminal differentiated, it is so named as a multipotent. So it has multiple potential. So this becomes a multipotent myeloid progenitor stem cell. So multipotent myeloid progenitor cells, and the lymphoid also is a multipotent multipotent lymphoid progenitor cells. Now, recall that the pluripotent hematopoietic stem cell, once it differentiates into the myeloid and the lymphoid lineages, we have just lost the pluripotent hematopoietic stem cell. There is no pluripotent hematopoietic stem cell in the bone marrow. Therefore, to maintain the process of hematopoiesis or to ensure the continuity of hematopoiesis, anytime that the hematopoietic stem cell is about to undergo differentiation, the pluripotent hematopoietic stem cell will self-renew itself. So this particular stem cell carry a self-renewal property. So it self-renews itself and creates a copy of itself, and that copy will stay in the bone marrow for subsequent hematopoiesis. And when the time in a hematopoiesis is about to start again, that copy will also create another copy, will self-renew itself. So this is what we call the self-renewal property of the pluripotent hematopoietic stem cell. So it self-renews itself before it undergoes this differentiation. So these multipotent myeloid progenitor stem cells, there are cells that are technically going to arise from them, and so we have this will undergo differentiation when the hormone erythropoietin binds to the myeloid progenitor stem cell. It will undergo differentiation to form the bus-forming unit erythroid, which will further undergo differentiation to form the colony-forming unit erythroid. All these is under the influence of erythropoietin, EPO, which is produced by the kidney. Because we are dealing with leukopoiesis and we are not interested in erythropoiesis, erythropoietin will not be involved in this process. And once erythropoietin does not bind to the myeloid progenitor cells, then the myeloid progenitor cell cannot move in the direction of erythropoiesis. And so this lineage will be cancelled in the absence of erythropoietin. Now, we can also obtain platelets. So we can obtain platelets from the myeloid progenitor stem cell. And the myeloid progenitor stem cell, and so let me actually move in this direction. So this myeloid progenitor stem cell will undergo differentiation. We have a stem cell here. So we have a stem cell here. We have another stem cell here. We have another stem cell here. This is stem cell, colony, forming unit, granulocyte, monocyte, eosinophil colony forming unit. And this is colony forming unit, basophil, baso. And this becomes my colony forming unit, megakaryocytes. So I have colony forming unit, megakaryocyte. Now, the colony forming unit, granulocyte, monocyte, eosinophil will undergo differentiation to form the granulocyte. So we have the granulocyte, monocyte colony forming units. The colony forming unit, granulocyte, monocyte. And here we will have colony forming unit, eosinophil. So this undergo differentiation. And from, we'll move to so this will give rise to the colony forming unit, monocytes. And this is the colony forming unit, granulocytes. Now, just as there are stimulatory factors in erythropoiesis, there are stimulatory factors that direct the myeloid stem cell as to which cell lineage is to go. So, assuming that this myeloid progenitor stem cell is being bonded to a hormone called thrombopoietin. Thrombopoietin, as the name implies, thrombo coming from the cell thrombocytes. So thrombopoietin will actually bind to the myeloid progenitor stem cell and direct the affairs of the myeloid progenitor to start committing itself in the lineage of megakaryopoiesis or thrombocyte production. Now, these stimulatory factors, so in the case of the white blood cells, we have some stimulating factors. Remember that white blood cells are classified into granulocytes and agranulocytes. The stimulatory factors in the leukopoiesis or in the white blood cell production include interleukin. So we have interleukin 3, interleukin 5, granulocyte monocyte stem cell stimulatory factor. So interleukin 3, interleukin 5, granulocyte monocyte stem cell stimulatory factor. And so when these act on the myeloid progenitor cells, then the myeloid progenitor cells will differentiate into the various types of the white blood cells. So we form the colony forming unit, granulocyte monocyte eosinophil colony forming unit. And so when we take this particular colony forming unit, we'll have the granulocyte, monocyte stem cell stimulatory factor that acts on the granulocyte monocyte eosinophil colony forming unit, and that will make this particular stem cell to differentiate into the colony forming unit granulocyte monocyte and colony forming unit eosinophil. So eosinophil is a granulocyte, monocyte is an agranulocyte, and the stimulatory factor is called granulocyte monocyte. So we have monocyte stem cell stimulatory factor and we have granulocyte stem cell stimulatory factor. Together with interleukin 3 and interleukin 5, this stem cell differentiate into the colony forming unit granulocyte monocyte and the colony forming unit eosinophil. So we have here, so let me put here, so here we have a monocyte stem cell stimulatory factor. So if I'm having monocyte stem cell stimulatory factor, it acts on this particular granulocyte monocyte stimulatory factor. It will make the granulocyte monocyte stem cell to differentiate in the lineage of what? The monocyte. And here we'll have, in this direction, means that we will need granulocyte stem cell stimulatory factor. So the granulocyte stem cell stimulatory factor will cause this colony to differentiate in the direction of the granulocyte lineage. Now, so interleukin 3 and interleukin 5 also plays an integral role in a monocyte stem cell stimulatory factor. Because monocyte is an agranulocyte, we call this stem cell stimulatory factor an agranulocytic stem cell stimulatory factor. And the stem cells that stimulates the granulocytes, they are called granulocyte stem cell stimulatory factor. So from the just indicating the nucleus, that's all the cells. So from the colony forming unit monocyte, the next stage to go is, so we'll form the first precursor cell of the monocytes, and that is called monoblast. The first precursor cell. So this is called monoblast. So we have our monoblast. So this is our first precursor cell called the monoblast. Then this cell will undergo differentiation and proliferation, increase in number, to give rise to what is called the promonocyte. Promonocyte. So to give rise to the promonocyte. Promonocyte. So we have the monoblast stage, which is the first precursor cell for monocytes. And after the monoblast stage, the next stage is the promonocyte. So the promonocyte, once we have a pro, the word part pro means before. So if the prefix pro means before, then this means before monocyte stage. Then it means that the next stage technically will be called the monocyte. So we'll form our monocytes here. So this will be the monocyte. So this actually are the stages of the monocyte production. This is monopoiesis, the production of monocytes. Now, let's continue in this lineage under the influence of the granulocyte stem cell stimulatory factor. So this one will undergo differentiation and proliferation to form the first precursor cell in granulocytes. And this first precursor cell, is called the myeloblast. So this is called the myeloblast. And the myeloblast is the first precursor cell. And this myeloblast technically is the same precursor cell. So a eosinophil, colony forming unit is eosinophil, will technically also give rise to myeloblast. So this will also give rise to the myeloblast. So here we have myeloblast. Then the basophil will also differentiate into the first precursor cell, also known as myeloblast. So this implies that all the granulocytes have a common precursor. Now, this granulocyte gene, as you see here, actually refers to the neutrophil. In a complete blood count, when we say granulocyte, we are technically referring to neutrophils in that context. In a different context, granulocyte is used to refer to neutrophil, eosinophil, and basophil. But in this context, the granulocyte we see here is actually for neutrophil. So from the myeloblast stage, so the myeloblast now, so we have our myeloblast. So what we have here is the myeloblast. And this myeloblast technically is the precursor cell for all the granulocytes. So all the granulocytes begins the first precursor cell for all the granulocytes, whether eosinophil, basophil, neutrophil, they have the same precursor cell. Now, this precursor cell will undergo differentiation and proliferation to give rise to the promyelocytes. To give rise to the promyelocytes. So, the myeloblast undergoes further differentiation to give rise to the promyelocyte. In all these stages of development, the cells start as a very large cell with a very big nucleus. So the nucleus of the cell is very large, and as the cell is undergoing differentiation and getting closer to the terminally differentiated cell, the nucleus begins to condense. And this means that the nuclear cytoplasmic ratio decreases. So when we say nuclear cytoplasmic ratio, I mean the size of the nucleus divided by the cytoplasmic size. So if initially all the precursor cells, the nucleus in the precursor cells are larger as compared to the cytoplasm. So if you have a very large nucleus, a very large nucleus divided by a very small cytoplasmic space, then when we divide, we will get a higher value. However, as this nuclear size is decreasing or is reducing as the cell is maturing, then means that as the nuclear size is decreasing, what happens is that the cytoplasmic space, as the nuclear size reduces, it creates a space in the cytoplasm, and this implies that the nuclear cytoplasmic ratio will decrease because we will now have a smaller nucleus divided by a larger cytoplasm, and that will result in a reduction in the nuclear cytoplasmic ratio. And so this myeloblast, actually in the cytoplasm of the myeloblast, it actually appears scanty. We do not see any noticeable granules in the cytoplasm of the myeloblast. By the time the cell undergoes differentiation and proliferation and enters into the promyelocyte stage, we see some granules begin to appear. So we begin to see some granules appearing in the cytoplasm. But these granules are actually called, they are non-specific granules. So we begin to see non-specific granules. Since this is the first time and we did not see granules in the myeloblast, and this is the first time we are seeing granules in the cytoplasm of the promyelocyte, since this is the first time we are seeing granules, these granules, anything first is called primary. So we begin to see primary granules. So primary granules begin to appear in the promyelocyte stage. These granules actually show an affinity for the azo dye or the azo stain. They show an affinity for the azo dye or azo stain. And because they are attracted to the azo dye, these primary granules are said to be azurophilic. Philic means loving. They love to be attracted to the azo dye. So the primary granules are also called azurophilic granules. Now, this promyelocyte will also undergo further differentiation. As we know, we are in the pro stage, and once we are in the pro stage, then it means the next stage, that means before myelocyte, then the next stage will usher us in the myelocyte stage. So the next stage here is the myelocyte. So we are in the myelocyte stage. Now, in the myelocyte stage, what actually happens is that these primary granules that we saw in the promyelocyte stage, they begin to disappear, and another set of granules begins to appear. And so we begin to see, so this is the nucleus. Remember that as the cell is maturing, the nuclear size is reducing while the cytoplasmic space is increasing, and that is why the nuclear cytoplasmic ratio decreases as the cell is differentiating to the terminal stage. So now we have another set of granules appearing. We have another set of granules. So we have another set of granules appearing in the myelocyte stage. And because this is the second granules to appear, these are called secondary granules. Secondary because they are the second to appear. So these are called secondary granules. The primary granules were described as non-specific granules because we couldn't have used those granules to tell whether this promyelocyte is actually a neutrophilic promyelocyte or basophilic promyelocyte or eosinophilic promyelocyte, because the granules that are in them are actually non-specific granules. They are not specific to a particular type of white blood cells. In the myelocyte stage, where there's another granules begins to appear in addition to the primary granules, that second granule to appear, we call them secondary granules. And these secondary granules are actually specific. They are called specific granules because we can use these granules to tell whether they are granules of eosinophil, they are granules of basophils, they are granules of neutrophil. So under this stage, in the myelocyte stage, if the granules that are appearing, so we could have 3, so we are having 3. So the myelocyte stage we have myelocyte for neutrophil, myelocyte for eosinophil, myelocyte for basophil, because we are now seeing granules that are specific to these types of white cells, and that will help us to differentiate or categorize them. And so we have So in this stage, what happens is that the granules are actually found in the cytoplasm. So we have the granules found in the cytoplasm, we have the granules in the cytoplasm of the cells. Now, these granules actually show affinity to the various dye components in a Romanowski stain, such as Wright stain or Leishman stain. The scientists who discovered these cells realized that when the myelocytes were stained, if the granules showed an attraction to the eosin part of the dye, the acid part of the dye, so we have some of the granules that were attracted to the eosin part of the dye. Remember that eosin is an acid. So the granules that showed an attraction to the eosin part of the dye, he called those granules eosinophilic granules. So we call this one, so we have eosinophilic granules. And because we are in the myelocyte stage, then this myelocyte in which the granules are showing affinity for the eosin part of the dye, these myelocytes are called eosinophilic myelocytes. So we have eosinophilic myelocyte. In other words, the granules of this myelocyte are basic in nature. And because they are basic, they will want to be attracted to the acid part of the Romanowski dye. And the acid part is called the eosin. So we have an eosinophilic myelocyte. Then we have then we have some of the granules showing an affinity for the basic part of the dye, and they were called basophilic granules. And because we are in the myelocyte stage, we will call it basophilic myelocyte. So we have basophilic myelocyte. And then we have another set of myelocyte. These cells actually technically did not show attraction to either the eosin part of the dye nor the methylene blue part of the dye. And these cells were actually described as neutral. And for the fact that they are neutral, we say they are called neutrophilic. So we have the neutrophilic, so this will be called neutrophilic myelocyte. So we have our neutrophilic myelocyte. So technically there are three types of the myelocyte. We have the neutrophilic myelocyte, basophilic myelocyte, eosinophilic myelocyte. So eosinophilic myelocyte means that this cell will undergo differentiation to become the eosinophil. This will become the basophil, and this will become the neutrophil. Now, from the myelocyte stage, so we are in the eosinophilic myelocyte, basophilic myelocyte, and neutrophilic myelocyte. From the myelocyte stage, the next stage is from the myelocyte stage, the next stage is we call it the metamyelocyte stage. So this technically is the metamyelocyte stage. Metamyelocyte. The nucleus here at this stage, the nucleus begins to indent. There is an indentation of the nucleus. So we have metamyelocyte for eosinophil, for basophil, and the neutrophil. Then from the metamyelocyte stage, the next stage is called the band. So we have the band. So we have the band, or the band eosinophil, the band basophil, and the band neutrophil. Then, so the metamyelocyte stage, this is actually the stage where cell division ceases. So cell division stops in the metamyelocyte stage, stops in at this stage. So it stops at this stage. So all the stages we mentioned earlier on is characterized by an increase in cell division, that is known as proliferation, and differentiation, that is moving towards becoming a specialized cell. So after the metamyelocyte stage, the next stage is called the band. So we have the band neutrophil, the band eosinophil, the band basophil. So from the band stage, then we'll go to the terminally differentiated cell. So at the band stage here, there was an indentation. So further indentation, then we'll now get a segmented cell, or the mature cell. So this band, they will undergo maturation a bit and they will be released into the circulation. So the band actually spends part of its life in the bone marrow and part of its life in circulation. Then they will transform into matured white blood cells. So we'll have a segmented, this is a segmented neutrophil, or neutrophil with what? Lobes. Technically, neutrophil has 3 to 5 lobes. Some books indicate 2 to 5 lobes. And for basophil, so for basophil, the terminally differentiated cell, it has, so this one, the neutrophil has granules, and these granules are actually lilac. They are not prominent. So the granules are actually not prominent. But when you take the eosinophil, sorry, the basophil, the granules of basophils are prominent. They are conspicuous, very large. And that of eosinophil, the terminally differentiated, eosinophil, they have pinkish granules, and their nucleus looks like a spectacle. So they have a spectacular shaped nucleus. So basically, these are the stages involved in the production of the granulocytes. And so we indicated that it begins with the pluripotent hematopoietic stem cell. that will undergo differentiation to form the myeloid stem cell and the lymphoid stem cell. Because we are producing white blood cells, our interest is not on the red blood cells and then the platelets. And so there are stimulatory factors, we call them interleukin 3, interleukin 5, and granulocyte monocyte stimulatory factor, which will actually act on the myeloid stem cell and cause the myeloid stem cell to differentiate into the colony forming unit granulocyte monocyte eosinophil and colony forming unit basophil and colony forming unit megakaryocytes. So the colony forming unit megakaryocyte is actually under the influence of the hormone called thrombopoietin. And so once we have these lineages of the white blood cells, this is acted upon by the granulocyte monocyte stem cell stimulatory factor act on this colony forming unit. It differentiates into the granulocyte monocyte colony forming unit and the colony forming unit for eosinophil. So this fractionate. Then we have the colony forming unit granulocyte monocyte will undergo differentiation to form the colony forming unit monocyte and the colony forming unit granulocyte. In fact, the stem cell that will make this particular stem cell to differentiate in direction is the monocyte stem cell stimulatory factor. And this monocyte stem cell stimulatory factor, monocyte is an agranulocyte. It means that this stem cell stimulatory factor is also called an agranulocyte or agranulocytic stem cell stimulatory factor, which make it to be committed to the monocyte lineage. Then from the monocyte, it goes to the monoblast stage. And this actually is the first precursor cell in the lineage of monopoiesis. Then this monoblast will undergo further differentiation to form what we call the monocyte. So the monocyte, so this is the pro-monocyte. And because it is the pro, it means the stage before the monocyte. Then the next stage will be the monocyte stage itself. So we have the monocyte. So this is actually in circulation. And when the monocyte leaves the circulation and they find themselves in the tissue, the monocyte becomes a macrophage. And so technically, all these stages we have mentioned, they are all happening inside the bone marrow with the exception of the monocyte stage which is happening, which is in the circulation. And once the monocyte leaves the blood and they enter into the tissue, they become a phagocytic cell. We call it the macrophage. Then the colony forming unit granulocyte, under the influence of the granulocyte stem cell stimulatory factor, it acts on it and it makes the colony forming unit granulocyte to differentiate into the myeloblast. And this myeloblast happens to be the first precursor cell for all the granulocyte lineage. So eosinophil, colony forming unit eosinophil will differentiate into the myeloblast under the influence of the granulocyte stem cell stimulatory factor. And then we have basophil also differentiating into the myeloblast. So all these three different types of cells have a common precursor. And we said that this common precursor, the myeloblast, will undergo further differentiation and proliferation to form the promyelocyte. And the promyelocyte is actually a stage that is characterized by granules. So the granules begins to appear in the cytoplasm of the promyelocyte, and because this is the first granules to appear, it is called the primary granules. In the myeloblast stage, we do not see any granules, so there are no noticeable granules, and in the promyelocyte stage we are seeing granules. And because this is the first time we are seeing granules, anything first is called primary, so we call them primary granules. And these granules are actually non-specific granules because they cannot help us to differentiate whether the promyelocyte is going towards the neutrophil lineage, the basophil or eosinophil lineage. Once this promyelocyte undergoes differentiation, as the name implies, pro means that before the myelocyte stage, then the next stage will be the myelocyte stage. Once we are in the myelocyte stage, this is where another granules begins to appear. And because that is the second granules will appear, those granules are called secondary, coming from the word second. So secondary granules. These granules actually are specific granules because they can help us to differentiate what type of granulocyte we are producing. So if and because of the differences in the staining characteristics of the granules, we are able to put them into 3 different myelocyte or myelocytic cells. So where the granules is showing an affinity, so if the granules of the myelocyte is showing an affinity for the eosin or the acidic part of the dye, that granule is said to be an eosinophilic granule. And because it is a myelocyte, then it is called an eosinophilic myelocyte. But if the granules are actually showing an affinity for the basic part of the dye, then that granule is said to be basophilic, meaning that it love base, and that becomes a basophilic myelocyte. On the other hand, if the granules are showing no attraction to either the basic part of the dye and then the acidic part of the dye, then we say it is said to be neutral, and that is called neutrophilic myelocyte. Then this myelocyte will undergo further differentiation and proliferation to form what is called the metamyelocyte. So at the metamyelocyte stage, this is the stage where the cell division ceases and there is no further cell division after the metamyelocyte stage. In all these stages is characterized by a decrease in the nucleus and an expansion of the cytoplasmic space. And this implies that the nuclear cytoplasmic ratio decreases as the cell is going through the terminally differentiated and cell. So at the metamyelocyte stage, we have metamyelocyte stage for the neutrophil, metamyelocyte for the basophil, metamyelocyte eosinophil. So we have metamyelocyte for all these lineages. Then from the metamyelocyte stage, it undergoes further differentiation to form a band cell. And this band cell, we have a band neutrophil. So there's actually an indentation in the metamyelocyte stage. There's a change in the nucleus, indentation, and it becomes indented more in the band stage. Then at the terminal stage, it becomes completely segmented. So we have a band neutrophil, then we have a band basophil, we have a band eosinophil, and from the band stage we move on to the last stage or the terminally differentiated cell known as the segmented cell. So we have the segmented neutrophil, and then we have the basophil, the end stage basophil, and then we have the neutrophil. So typically when we examine a peripheral blood smear and we see an eosinophil, the nucleus of an eosinophil looks spectacular, like a spectacle, and the cytoplasm appears pinkish because the eosinophil is showing an attraction to the acidic part of the dye. That is how we have the name eosinophil. This cell actually showed an attraction to the eosin part of the dye. So we have eosin as a stain, and the cell is attracted. Attraction is called fill. So attraction to the eosin part of the dye. Then we put the vowel O in constructing a medical where we put a vowel between it. So that becomes eosinophil. This cell is called a basophil because it showed an attraction, that is fill, to the basic part of the dye. And the basic part of the dye is called bas. So that is what? Baso. So we form basophil. The cell showed attraction to neither the acid or the basic part of the dye. So that cell is neutral. So it becomes neutrophil. So that is how we have the names eosinophil, basophil, neutrophil, based on their affinity for the individual components in a Romanowski stain.